Passivhaus Standard was developed in Germany by a German building scientist and a Swedish building scientist in the early 90s. Got 20 odd years of collected data from built buildings to show that it's reliable, things do what they say they do. These building scientists were looking at so-called eco-buildings across Europe, looking at them and saying, why don't these buildings perform? Why are they uncomfortable? Why do they still use more energy than they said they were going to? Why are they not living up to their promises? They can't not obey the laws of physics. They're still building. So what are the laws of physics that they're not paying attention to? Why isn't it working? So it's a very rigorous standard. It's a performance standard, so it doesn't say you've got to use it in concrete or brick or timber or whatever. It's really about the outcomes, the performance of the building. It's got a very rigorous quality assurance aspect to it, so the design, the energy modelling and the building as it gets constructed get checked by third parties to make sure that what's built is what's designed. What's designed is accurately correct and not fudged in the energy model or in the details. It's also actually a comfort standard, and actually there's more criteria to meet Passivhaus that are in human comfort than there are in energy consumption. So energy consumption is a couple of benchmarks for the amount of heating or cooling energy needed for the building and benchmark for the total amount of primary energy. So primary energy is the amount of energy generated, not the amount of energy consumed. So if you generate energy in the nuclear power station, so much is generated, you lose a bit through the process, you lose a bit through the national grid distributing it, and then you use a certain amount in the building. Primary energy is what gets generated, not what you use. So it's kind of factorised up, so you might use a certain amount, but actually the amount generated needs to be 1.5 times that amount just so you can use that. So it's measuring actual energy, primary energy. And it's climate specific, so wherever you want to design a building anywhere in the world, it needs accurate climate data for that precise location. So if you're designing a building in Wales, or if you're designing a building in Wolverhampton, like we've been doing, they're using different climate data sets because they're different climates, even that close together.